Hi, this is Kemal ERKİşi. I'm working as an associate professor of economics in the Department of Economics at Antalya Bilim University. First of all, I'd like to state that it's a great pleasure for me to participate in the 18th International Balkan and Near East Economy, Business and Management series. Our research topic is the impact of immigration on unemployment in the case of Turkey. I'm going to start with a research question. Political and economic instability and conflict environments at the level of developing countries have increased immigration significantly in the last decade. And the economic, political, and the cultural impacts of immigration are intensely the subject of scientific research. And in this research, we will examine the impact of immigration on unemployment, which is one of the economic consequences, and try to find the answer to the question whether immigration really has an effect on unemployment in the period of 2000 and 2021 in Turkey. Um, we're going to start, or we will carry on with the model specification. In our model, the data sets includes 22 observations between 2000 and 2021 belong to the series of unemployment, immigration, and economic growth. And the functional form of the model, which is defined, unemployment is a predicated variable, and immigration and economic growth as predictor variables can be described as an equation 1. And equation 1 says us that unemployment is a function of immigration and economic growth. And to employ into the empirical analysis, this functional model seen in equation 1 can be expressed statistically as an equation 2. And in equation 2, the beta 1 and the beta 2 are the coefficients of the regressions that represents the change in unemployment corresponding with per unit change in immigration and economic growth. And T represents the time trend, and alpha symbolizes the constant, and while U represents the error term that explains the deviation from the trend in each year. Okay, in order to convert the static model in equation 2 to dynamic model, the lagged values of the series are taken and can be described in vector autoregressive or its so-called word system as in equation 3 and equation 4 and equation 5. And as you've seen, there's a term as ECT, where ECT represents the error correction term, and it is a lagged value of the residuals obtained from the contigrating regression of the dependent variable on the regressors. An ECT contains long-run information derived from long-run conjugating relationship. And from gamma 1 and gamma 3 is the speed of adjustment parameter. And from beta 1 and to beta 9, short-run dynamic coefficients of the model. And starting from U1 to U3 presents the residual and the N as the number of leg length. As you've seen in table 1, the descriptive statistics of the series, unemployment, immigration, and the GDP. There's observation here. We have 22 observations. The mean, standard deviation, and the minimum and the maximum values of the series. The degree of the integration of the series is very critical issue for causality analysis. Therefore, stationary of the series was examined with augmented decay Fuller unit root test, it is so-called ADF test, and the outcomes were reported in table 2. And table 2 shows the p-values of augmented decay Fuller t-statistics of the series at the level and at the first difference. And the results reveal that a series of unemployment, immigration, and economic growth are stationary at the first difference. Therefore, the series are integrated at the same level. This level is I1, which means integrated level is 1. When the series are stationary at the same level of differencing, there is a contegration, then the vector autoregressive model, which is called the WAR model, will be combined with the error correction model to become vector error correction model. And we will use this vector error correction model to estimate the parameters of the model we defined previous screen. Okay, actually, vector autoregressive is one of the special forms of system simultaneous equation, and vector autoregressive model can be applied if all the variables are stationary at level. However, if the variables in the vector are not stationary at level, the vector error correction model is used if the model has at least one or more configuration relationships between the variables. The existence of a long-term relationship will be tested with the Johansen configuration test. And before carrying on further, it is needed to select optimal leg length. For this purpose, leg order selection criteria test was employed and they reported in table 3. And the indigenous variables are unemployment, immigration, and GDP. And the appropriate leg length is specified as 1 by Schwarz-Bayesian information criterion and the Han-Quinn information criterion, while 2 by final prediction error, which represent with FPE, and the 4 by Akaika information criterion, and sequential modified LR test statistics. Because of the proper leg length was selected as 2 by Han and Quinn information criterion and Schwarz-Bayesian information criterion, it is decided to choose 2 as optimal leg length value. The configuration between the series will be investigated with the help of Johansen configuration. Null configuration, the null hypothesis, is tested in return for the alternative hypothesis that represent a configuration relationship between variables, and specify the existence and the number of vectors of configuration, the outcome of the required trace statistics, and maximum eigen statistics are displayed in table 4. Since the p-value of the trace statistic and the maximum eigenvalue statistic are less than 5%, the null hypothesis of no co-integration is rejected. Since both trace and the maximum eigenvalue test indicate 2 co-integration equations at the 5% level, that is, co-integrated vectors between the variables, we concluded that there is a long-term relationship between unemployment, immigration, and economic growth. Table 5 includes vector error correction model outputs of the estimation of long-term parameters. The coefficient of the lagged value of unemployment, which you've seen in the first line, is negative and 0.15 and significant at 1% level. This result confirms the long-term relationship. The bottom part of the table shows the long-term coefficients of immigration and economic growth, and both variables are significant at 1% level. And the outcomes of the vector error correction model indicate that 1% increase in immigration leads to an increase of 0.5% in the unemployment rate, and the 1% increase in real output reduces the unemployment rate by 2.34%. Okay, once we finalize the estimation of the parameters, it is suggested to test the stability of the model. We're going to use 3 diagnostic tests to assure if the model is stable or not. In this model, we tested autocorrelation test, and the null hypothesis of no serial correlation tested with the help of vector error correction residual serial correlation LM test, and the outcomes reported in table 6. As the p-value is greater than 5%, the null hypothesis is not rejected. It is concluded that there is not autocorrelation up to 4 lags. And the second one is the normality, and the residual normality test performed by vector error correction residual normality test and reported in table 7. As the joint p-value is 0.75, the null hypothesis of residuals are multivariate normal is not rejected, and they calculated that and concluded that the residuals are multivariate normal. And the third one is the eigenvalue stability condition in table 8, showing the eigenvalues of companion matrix and their associated module. And the table further reminds us that the specified vector error correction model imposes non-unit modules on the companion matrix. Therefore, all the eigenvalues lie inside the unit circle, as you see in the right hand side of the table. And the output indicates that there is not a real root at the about 95% confidence level. And these three stability tests indicate that there is no autocorrelation, residuals are multivariate normal, and there is no unit modules. And we can say that our model is stable. The outcome of the vector error correction model again indicate that a 1% increase in immigration leads to an increase of 0.5% in the unemployment rate, and a 1% increase in real output reduces unemployment rate by 2.34%. And in this case of Turkey, it is concluded that immigration increases the unemployment rate. However, unemployment is only one dimension of the immigration. It is important to consider the impact of immigration on the country's output level, an average wage level, income distribution, crime rates, which is social dimension. And to assess the economic consequences of immigration, it is recommended to consider all the consequences of the impact of immigration together. And we investigated just the one of economic consequences. This is unemployment. Okay, thank you for listening to me, and should you have any questions, please do not hesitate to get in touch with me via my email you see on the screen. Thank you very much again, and I wish you have a wonderful day.